Hi, and welcome to the world release of New Electromagnetism version 5. What you're looking at is the Physics 2 simulation software. The animation you're showing we were going to schedule for this video, but it's going to be put off to the next video because we ran out of time. So I'm going to put this Physics 2 simulation off to the side. So what we're going to discuss is Electromechanics New Electromagnetism V5 Introduction. This is the world release. It's been released to my Patreon members now. They've known about New Electromagnetism V5 for at least a year, if not longer. This is the punch list of the comparison between classical theory and all of the versions of New Electromagnetism up to V5. Yes, it's taken me 30 years to get a version of electromagnetism that is free from counterexamples. This yellow here means that classical theory gets the correct answer, but it violates the laws of physics. It violates locality in this case here. The rules of acquisition are things like locality, overunity, ambiguity, things like that. Things that a good law of nature should not have. And classical theory is plagued by the rules of acquisition are a series that will be covered separately, but we will make mention of them in this video. Get your appetite whet to them. These will all be explained as the video series is progressing. For this week, okay, we were going to start here with that, but we ran out of time, but we will put a little bit in next time. We're going to cover induction issues, which classical theory fails miserably. And we're going to start off with a precursory derivation just to show you where new electromagnetism comes from. New electromagnetism comes from a precursory field model. All of classical theory is derived from a bunch of empirical experiments. Okay, so again, we're going to give you the introduction to the models. We're going to do precursory derivation. We're going to get into the triple loop and the linear inductance experiment. And we were going to get into the field geometry animations in a look ahead, but we're going to save this for next time. So new electromagnetism V5 is derived from a primordial field called the pretonic field. It is a matrix field, not a vector field. Its amplitude is isotropic, spherical. And if you want to know where to find more about the derivation that we're about to get into, I'll show you that in a moment. Okay, so the pretonic field, if you take the time derivative of it and then multiply it by the r direction vector and the target charge, you will find the force on the target charge. This results in two derivative components. One is the inertial force model, and the other one is the magnetic force model. We don't say fields. These are not fields. These are derivatives of the primordial field. These are manifestations of the field. And if you notice, our inertial force model, in the past it was called new induction, looks just like F equals minus ma. This is the inertial force model. The applied force model is F equals ma without the minus sign. Okay, the electric force model is derived by taking two systems of pretons and computing all the interactions between them. That works out to this model here, which looks remarkably like Coulomb's model. And because pretons are the precursor to matter, and matter is affected by its velocity relative to the medium, we call transvariances. Other people might call them relativistic effects. So there is what they call time dilation in electromechanics is not time dilation, it's process dilation. Time doesn't change. What happens is the processes of matter slow down as a function of the velocity of a system relative to the medium, because the pretons can only travel at the speed of light. And so if the system that contains those pretons are translating at a velocity, well then the rotational speed of the pretons have to slow down appropriately. It's as simple as that. There's no voodoo here where, you know, in relativity they say, well, things have to slow down. It's time dilation, but they do not ever give a mechanism. Here's a plain and simple mechanism. Okay, and also it can be given that the source charge and the target charge can have their own separate framework of slowing down, which alters the coupling of individually. But for the purposes of this video series, we're going to be using the simple solution when velocities are much, much, much slower than the speed of light, which would be then normal Coulomb's model. These three models combined comprise what is known as New Electromagnetism version 5. And these are for the far field effects, where the distances between the charges are much, much greater than the size of the second order systems of pretons. And in New Electromagnetism ethereal mechanics, the units of force, the natural Newton, is current squared, or square amperes. And so the first model we have is Coulomb's model, which we just looked at, the magnetic force model, and the inertial force model. But because natural Newtons aren't really well known, and to compare with legacy results as well as measurement equipment, we can express the results of New Electromagnetism in terms of legacy units. We use blue typeface for legacy units. All you have to do is multiply each one of the equations by Km. Km is mu naught over 4 pi, and that puts these into kilogram meter per second square units, which are compatible with legacy instruments. Okay, before we continue on, let me show you where to find all this precursory stuff. Okay, you go to www.distinti.com. Let me bring it over. And you go to ethereal mechanics now and roll down. You will find there's book 1 is transvariance. Book 2 is constructs. There are videos for this. I haven't had a chance to link them in, but if you go to the electrogravity page, the electrogravity is the precursor to New Electromagnetism V5, where the pretonic field is discussed. Right now available is a version 1.0 paper in PDF form. There is a version 1.1 which will be released to the public soon. It's presently available for Patreon members only. That will be out like in the next week. And okay, so they're having a problem with the internet right now, but these were the videos on YouTube. Sorry about that. My link is down. Let me see. Okay, that's where you find everything. If we look at New Electromagnetism V5 and compare it to the legacy models, these are the legacy models. So this is Coulomb's law. You can see they pretty much match. Now I cut and pasted these from different parts of the internet, so their formats and their styles are all over the place. I apologize for that. Okay, this is the magnetic field model, which is close to F equals Q V cross B. The E here is marked out because it's already accounted for up here. So ignore that, this in this equation here. Okay, now this accounts for much more than this. Down at the bottom is the inertial force model, which is closest companion would be Faraday's law. And both of these require the Biot-Savart model for the field. Now people say, well, why don't you put Maxwell's equations here? My friends, Maxwell's equations are derived from these fundamental measured empirical models. I'm going to show you, other than Coulomb's model, that these are incomplete and don't give all the answers. If they don't give all the answers, then there's no way the derivative of Maxwell's equations could. I have another video where I show there's all kinds of problems with the derivations of Maxwell's equations by themselves. The problem with that is most of the people that claim to be experts in Maxwell's equation can't follow it. So there's no sense me even going down that path anymore. I'm just going to show you at the base. We're going to show you that in this video, that these do not get the right answers under all conditions, where so far these give the correct answers under all conditions. The difference here is these are vector equations, these are matrix equations. And so these have much more degrees of freedom and can account for much more in the field of electromagnetism. So the first experiment we're going to look at is the tri-loop experiment. The tri-loop experiment is looking at the inductance of 3 loops of wire. Okay, in the textbook John David Jackson, page 234 of Classical Electrodynamics, 3rd edition, he has the inductance of an inductor where the radius of the loop of wire is A, and the radius of the diameter of the wire, the radius of the thickness of the wire, is B. And this is the equation. In New Electromagnetism version 5. This is what New Electromagnetism version 5 predicts. I'm comparing that with John David Jackson here. The experiment where you run can be run by a school kid. Okay, you just get 3 little dinner plates. They're all the same. One is 30 gauge wire, one is 22 gauge wire, and another is 26 gauge wire. And just glue them to the plastic dinner plate, and then get your trusty, rusty Agilent LCR meter and take the measurements. This is the average of 2 sets of measurements. This is the result for the 22 gauge wire. This is the result for the 26 gauge wire. This is the result for the 30 gauge wire. So now let's go and see what John David Jackson says. That's his result from the equation you saw. This is the result from New Electromagnetism V5, which is much closer. Now, with the Agilent LCR meter, I've had a good track record that the device gets within 2% of the actual values, and you can see that New Electromagnetism version 5 fits within the error margin of the instrument. And the reason I say this is because I have a lot of data compared. Now, this is measured versus computed. This is computed, so in this data here, there is also numerical integration error. The values here were done analytically, so there is no numerical integration error. So we should be able to do better than this. The average of this is 2%, so 2% is fair for the precision of the experiment. Okay, but to be fair, John David Jackson's derivation is done according to accepted theory, which has oversubscribed some effects. Once corrected, it matches the results from New Electromagnetism V5. See the foundation playlist. If you go back here, so go back to the website, go back to the first page by clicking on the Julie logo. And down here, you'll find the foundation. And these are the videos in the playlist, how it should be read, and we'll go through and show you the correction for Jackson along with the plotted data and all that other stuff. This shows how the experiments were built, how they were measured, how the new induction model was. So this is all here. And this also shows preliminary stuff for New Electromagnetism equals MC squared, inertia, mass, matter, blah, 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 blah. There's a lot of really good stuff here in the foundation series. They're long and they're boring because I produce long, boring videos. I don't know how to make them any better. I'd like to hire people to help me make them better. But anyway, even though we've corrected it, so in spite of the fact that I've corrected John David Jackson's derivation, there's other problems with self-induction. For example, okay, the classical theory can't explain how a ground plane or 2 ground planes affect the inductance, whereas I've gotten excellent results with New Electromagnetism V5. This was done for 2007 for my graduate thesis. And no one else, there were a lot of papers out there that tried to get approximations with ground planes, but they were more empirical than they were derivatives of theory. And I couldn't find anybody that had any paper that did any work with dual ground planes, and New Electromagnetism has excellent results. If you go back to the website and you go to the main page, and you should find my thesis. Oh, I don't know where the thesis is. Just go to distinti.com, docs, D-O-C-S, like that. It'll let you browse. And here is nethesis.pdf. So all the present papers right now are in here. You just have to go to docs. I don't know where the link is. There's a link on the main page. Just go to the docs subdirectory. It's browsable. Okay, so the next experiment we're going to look at is the new experiment that we just came out with last month called the latex experiment, which stands for linear 8-inch inductor experiment. This is a corroboration that the M field is spherical. So using new electromagnetism, or the calculation for the inductance of a straight piece of wire is this. Now, unfortunately, I used L for length and L for inductance. So the blue L is the inductance, the black L is the length. And the reason why we got that is because we're converting the L to natural units, which is Henry. Legacy units, which is Henry. Okay, now this video I got from a clip is from this channel up here. It's called Essential Electrician or Essential Electronics or something like that. He does the correct derivation, the same derivation that's in the books. I'm not picking on this guy. I just picked this from random. He does the derivation exactly according to the book. There's no problem there. Okay, but let me show you what we say is happening here. Okay, the one thing you should notice is that the legacy value for inductance has the inductance independent of the thickness of the conductor. Okay, the other issue that you should notice, and I've taken his equation here and I put it up over here. His equation is Km over 2 times the length of the conductor, or it's mu naught over 8 pi times the length of, same thing. Okay, nowhere in here is the thickness of the conductor represented. That is what physicists believe, that the thickness of the inductor has nothing to do with the inductance of a linear wire. And I'm going to prove to you that that is only the case if you're considering a toroidal field. If you're considering a spherical field, the radius does indeed have a massive effect, and we're going to show that to you experimentally. Okay, but one of the things, notice that the inductance is independent of the wire thickness. Again, that's a character of the toroidal or transverse field. Second is the result shows that an inductor has less inductance than free space. This is illogical. The inductance of free space is pretty much mu naught over 4 pi. Or some people say it's just mu naught. In any case, you can't have an inductor that has less inductance than free space. That's scientifically illogical. And this has been, and this isn't, I'm not faulting this guy, this has been in the physics books for hundreds of years. It makes no sense that a wire should have less inductance than free space. That is completely ridiculous. And why no one has ever looked at that, they just do the math, they get the right answer, and they think they know what the hell they're doing. They have no clue what they're doing. The actual inductance of an inductor of a straight piece of wire should be much, much greater than free space. And I'm going to show you that is indeed the case through this groundbreaking experiment. This is the first public release of this experiment. Okay, now as an alternative, just to give you something to gnaw on, if I took the new electromagnetism and I limit it to only the transverse effects or the toroidal effects, and then took the derivation again, this is the result I would get. And this result is pretty much approximately equal to this, which has virtually no, there is a slight correlation to the radius or the thickness of the wire, but essentially it's pretty flat. And I think this proves that if you have a transverse only field, you're going to get an inductance of a straight wire that's independent of the radius or diameter of the wire. That is the characteristics of a transverse only field or a toroidal field, whereas a spherical field does have. So now, what we're going to do in this experiment, for this latex experiment, we measured, was it 9 pieces of wire sitting here? This is the diameter in inches. This is the length in inches. Shown here are the results of the calculations. On the left side is the calculated inductance in henries for the 8-inch wire inductors, and this is the wire diameter in inches. As you can see, as the wire diameter gets smaller and smaller and smaller, the measured inductance starts going asymptotic. This is characteristic of the spherical field. Here is the inductance if I took new electromagnetism and just limit it to a transverse only or toroidal field. And as you can see, it's very well decoupled from the radius of the wire, or the wire diameter, same thing. Okay, this is what classical theory said. This is what everybody has derived. This is what's been in the textbooks for 100 years or more. They keep repeating the same crap and don't even bother to do an experiment. They charge you hundreds of dollars for textbooks and can't bother to do a simple experiment to validate that what they're pushing out to all these unsuspecting students is complete garbage. Complete garbage. Now let's go to the measurements. Well, I guess I should show you the measurements before I declare it's complete garbage. Okay, this is the measurement instrument. This is the fixture called the latex fixture. I have videos that show exactly how this experiment was run with nothing cut, showing everything that's going on and how these things were built. I've got a newer version, which should be a little bit less hokey. The problem with this is these bars float in there a little bit. I made a new one, 3D printed, where everything's socked down a little tighter. And I think because of the slight wonkiness in here, we get slightly wonky answers, but it doesn't really matter because they follow the spherical field trend line the best. I think these little diversions here are due to the wonkiness of the fixture. I built a new fixture. We're going to repeat the experiment, see if we can't lock down this wonkiness. Even with the wonkiness, it's nowhere near the toroidal field results from either castrating new electromagnetism to a toroidal field or the value obtained from classical theory. Nowhere even close. And because of the slight up curve matches the up curve for a spherical field, this shows irrefutably that the field phenomenon that we've thought was donut-shaped for the past 150 years is spherical. Classical theory is dead. It's over. Time to get rid of it. Maxwell's equations are hereby invalidated. Everything related to that is now invalid. Okay, now I have a warning for the physicists out there and the people that think they're intelligent on this classical theory and they're going to prove me wrong. If you apply vector magnetic potentials to this experiment, you are violating the laws of physics. If you read your textbooks and you understand that vector magnetic potentials were derived from Faraday's law, which needs a conductor that closes around a section of field lines. Straight wire cannot enclose field lines. It's physically impossible. And that's why in the textbook, if we again agree not to attribute any physical significance to any magnetic field we obtain from 48 vector magnetic potential until the entire closed path in which the current flows is considered. This is from a very common textbook, William H. Hyatt Jr., Engineering Electromagnetics. I have the 4th edition and I have the 11th, or I don't know, later edition somewhere else. Okay, again. Okay, but somebody's going to say, well, gee, if we rearrange the vector magnetic potential equation there from a differential around a length to a point charge equation, it looks very, very remarkably like the pretonic field model. Okay, don't be fooled by this. The vector magnetic potential equation is a vector equation and has limited application. The pretonic field is a vortex matrix equation with many more degrees of freedom. It is also the basis from which all of new electromagnetism V5 is derived. Matter of fact, even gravity, the force of gravity is derivable from this. Go ahead and try to do that with this. You're not going to come anywhere close. Okay, so let them leave it at that instead of beating a dead horse on this. Okay, again, this is the final wrap-up, and we're going to cover more of this in later editions. And right here, this is self-induction for closed loops and open loops and legacy fails. I was going to hope to get into some of the rules of acquisition, but we've run out of time. Okay, because I need to get this video to production. The remaining items will be added to the front of the next video. Our premiere night for new electromagnetism V5 going forward will be Thursdays from now on, not from noon. It should be from now on at 9 p.m. I'm going to try to get a video done each week until any V5 is fully released. Now, the V5 paper is published at the U.S. Patent and Copyright Office. This is the registration number. So if you can, I believe you can download it from them at any time you want. Okay, there is a new version of NEV5, version 5.1. Basically, mostly typos and some additional material, but no change in the basic form or structures or forces. Mostly typos. It's going to be released to Patreon First Class and above at the conclusion of the electrogravitic experiment, which should hopefully be completed before the end of next week. Please help out. If I could hire people to help do these videos, somebody who has a nice speaking voice, whatever, hire people to put more animations and stuff in these videos, that would be great. I would appreciate it. Right now, I have to do everything, And I'm not too bad at it if I have the time, but trying to develop the science and the technology takes a lot of time. So if I had nothing to do but make videos, that would be a lot easier. So if you could help out, $5 a month, and you'll see all the technology videos at least 4 weeks before the rest of the world. Please become a Patreon member. This is a repository where you can find everything. There are links here to the Patreon, the blog site. This is the blog site. Unfortunately, I don't get a lot of time to spend here. When people let me know that there's something special there, I will go look. But once I get done with cosmology, I'm hoping to take a break and spend a lot more time hearing what people have to say all over the place. So I'm kind of hard to get a hold of because I'm so damn busy. This is the Ethereal Mechanics YouTube site, the main one. All new videos will be released here, not at the old site that we had. I believe you can get here by etherealmechanics.com. Oh, the blog site is etherealmechanics.info. That's the difference. Thank you. No more voodoo physics.